The metric system is a base 10 system. There are base units such as meters, moles, and grams that are used to signify what we are measuring, whether that be mass, distance, volume, or many other commonly measured things. One might wonder why exactly the metric system is needed. If we are working with really small numbers, such as 0.00614 moles of a substance, or even 0.0000887 moles, using a smaller unit of measurement would provide us with a more manageable number, such as 6.14 millimoles or 8.87 micromoles. The metric system contains different prefixes for each power of 10 so that we can convert very large or very small numbers into more convenient numbers. Here are the most common prefixes that describe how the metric system works. Keep in mind that 10 to the 0 power equals 1. This represents our base unit. As you move up from there, your unit will represent a larger number of base units. For example, 1 kilometer is equal to 1,000 meters. As you go down from the base unit, your unit will represent a smaller fraction of base unit, such as 1 millimeter equals 1,000th of a meter. A base 10 system means that every unit you go up or down requires you to move the decimal place over one place. For example, 4.61 grams is equivalent to 0.461 decagrams. Similarly, 4.61 grams is equal to 461 centigrams. To go from grams to decagrams, it is one jump on the table, so we are only moving the decimal place one spot. For the grams to centigrams conversion, notice the difference in magnitude. Since there are 2 steps in the table, the decimal place must be moved 2 spaces over. It is helpful to memorize the prefixes used in the metric system, and there are many helpful mnemonics to help you achieve this. Here is one example. Kids have dropped over dead converting metrics. You skip over the base because there are no prefixes used for base units. The prefixes kilo, hecta, deca, deci, centi, and milli only have one magnitude of difference between them, but this is not the case for the entire metric system. Once numbers begin to get extremely large or extremely small, there are fewer common units used. For example, giga, which is 1 billion, or mega, which is 1 million, are common units used for really large numbers. This would turn 396 million grams into 396 megagrams, or 0.396 gigagrams. Similarly, nano, which is 1 billionth, or micro, which is 1 millionth, are used for really small numbers. This would make 0.0000596 liters equal to 5.96 microliters, or 5,960 nanoliters. Although very large or small, these prefixes are still very common in the science world today. A common problem when converting metrics is not knowing whether you multiply or divide to get your new number. Let's convert 2,091 meters into kilometers. We know that the magnitude of difference between meters and kilometers is 10 to the third, but what calculation do we need to do to achieve the conversion? A kilometer is bigger than a meter, so that means that there should be fewer kilometers than meters. To make the number smaller, you divide rather than multiply by 10 to the third. This can easily be done in one's head by simply moving the decimal 3 spaces to the left. Giving us 2.091 kilometers. There are other situations that ask you to convert a measurement without starting from base units. Let's say we were converting 0.0000423 hectometers into millimeters. Hectometers are 10 to the 2 times the number of base units, and millimeters are 10 to the negative 3 times the number of base units. We see that these two units are 10 to the 5 magnitude apart. Since millimeters are smaller than hectometers, we must have more millimeters than hectometers. In this case, we would multiply by 10 to the 5, or move the decimal place over to the right 5 times, giving us an answer of 4.23 millimeters. Solving these types of problems for cubic or square units are a bit more complicated. When students try to convert centimeters squared to meters squared, they often use 100 centimeters squared equals 1 meter squared as the conversion factor as follows. We cannot simply move the decimal the number of magnitude of difference when dealing with the unit squared or cubed. If we look at the squares that represent the area, we can see that the assumption is false. A 100 centimeter squared area is achieved by a 10 centimeter by 10 centimeter squared. A 1 meter squared area is achieved by a 1 meter by 1 meter square. Comparing these two objects side by side, it's obvious that they are not equal. If we were to look at the units in the equation above, we see that once the units are cancelled, we are left with centimeters times meters. This is not a useful or meaningful unit. The easiest way to handle a problem like this would be to square the conversion factor. Instead of dividing by 100, we would divide by 100 squared, or 10,000. Doing this will give you the actual answer, which is 0.01 meters squared. For our last problem, let's try to convert 25.7 centimeters cubed into decimeters cubed. Please pause the video and give this problem a try. As you can see on the table, the magnitude of difference between centimeters and decimeters is 10. Because we're using cubic units, our conversion factor must be cubed. Our equation should look like this. Once you cube the conversion factor, we can calculate and find our answer to be 0.0257 decimeters cubed.